Very good morning, students. I am very happy today because we are coming to the end of this lockdown period. Hopefully, fingers crossed. I am hoping that the lockdown ends very soon by May 3rd, as already announced by our Honorable Prime Minister Mr. Narendra Modi, that the lockdown will be up to May 3rd. But I don't know it will be extended or not. So I am crossing my fingers for that it doesn't extend. But keep in mind, having said that, the students must not forget that they must continue with their studies. And so today I came up with this new video where I'll be explaining one unit from one chapter, Motion in One Dimension, that is the second term chapter, Unit 1 for class 9. So this unit, before I go in details on my board about this chapter, I would like to tell you that this unit includes lots of technical terms, and today I will be explaining you those technical terms. Okay, so let us start. So the name of the chapter is Motion in One Dimension. I will be discussing unit 1 of this chapter. It is meant for class 9 and it is a second term syllabus for class 9. So in this chapter, as I told you, in this chapter you will be coming across some technical terms. What are those technical terms? The very first technical terms that you must understand is rest. What is rest all about? As far as rest is concerned, when a body does not change its position with respect to place and with respect to time, then we say that the body is in rest. For example, a book is lying on the table. Now, if a book is lying on the table, this book is not changing its position with respect to place, neither with respect to time. Hence, we tell that the book is in rest. This topic you have already studied in lower class. I just explain this topic so that you can again recapitulate those previous memories and then concentrate onto this new unit. The next terminology which will be accompanied with this term rest is motion. The next term is motion. What is motion all about? Motion is just opposite of rest. If a body changes its place with respect to time, if a body changes its position with respect to place and with respect to time, we say that the body is in motion. For example, right now I am standing here. I am standing in front of you. Now, if I change my place like that, I am walking right now. If I change my place with respect to place, my surroundings, and with respect to time, then I am in motion. As simple as that. Example, as far as motion is concerned, example, a moving car. As a car moves, it is changing its place or position with respect to time and also with respect to the surroundings nearby the car. So this is rest and motion all about. But before moving on to the next terminologies, the technical terms related to this particular unit, do remember that rest and motion, they are considered related to each other. They are correlated to each other. These rest and motion, they are correlated to each other. Correlated to each other. Now, how they are correlated to each other? Means, in a coin there are two sides. Every coin has two sides. Okay, whenever in a cricket match, before the match starts, the two captain comes up with a toss. They toss a coin. Now, when the coin is tossed, obviously there will be one side will fall onto the ground, and the captain, whoever appeals for that particular side, will win the toss. Maybe he will elect for batting or fielding, and the two sides are either head or tail. Similarly, we say that rest and motion are two terms, means they are correlated. Okay, a body which is in rest can be in motion at the same time. Okay, right now I am in rest because I am not changing my position with respect to place, with respect to the surroundings of this room, the four walls of the room, and with respect to time. But if I compare myself with the motion of this earth, the revolution of this earth, then I can say that I am in motion. So, as I say that rest and motion are related to each other, it means that a body which is in rest in one particular time can be in motion also in the same time. Another example I am citing before you. This example is, suppose you are sitting inside a bus and the bus is moving. Now if you compare yourself with the surroundings inside the bus, the surroundings inside the bus, the passengers, the co-passengers which are who are sitting next to you, then you are in rest. But if you compare yourself with the surrounding outside the bus, then you can see that the trees are passing by, the animals are passing by, some other vehicles are passing by, then you can say that you are in motion. So, in one way you can tell that a body which is in rest in one particular time can also be in motion in the same time. Now we will move on to the next terminologies. So, when I go to the next terminology, I should first explain the meaning of this chapter, motion in one dimension. Motion in one dimension is also known as rectilinear motion. Okay. Now what does motion in one dimension means? Motion in one dimension means, the meaning of motion in one dimension, as long as a body continues to move in a straight line, as long as a body continues to move in a straight line, we say that the body is executing motion in one dimension. It is also known as rectilinear motion. For example, a car moving on a straight highway is executing motion in one dimension or rectilinear motion. Am I clear? Hope it's clear. The next topic after motion in one dimension is scalar quantities, scalar and vector quantities. Scalar and vector quantities. These topics, scalar and vector quantities, I have explained in chapter 1 of class 9 physics. I have explained the scalar and vector quantities. I will explain once again. Now, scalar quantities are those physical quantities which have only magnitude and no direction. For example, mass. When you go to the vegetable vendor and ask the vendor to give you 5 kg potatoes or onions, you don't say the vendor that give me 5 kg north potatoes or give me 5 kg south onions. You simply say 5 kg, where 5 is the magnitude and kg is the unit. So whenever any physical quantities is accompanied with magnitude and unit, we say them scalar quantities. Example, mass, length, time, temperature and so on. So these physical quantities which are associated with only magnitude and no direction, they are known as scalar quantities. But as far as vector quantities are concerned, they are associated with magnitude, unit as well as direction. When I tell you that a person started walking 5 meter in a highway, okay? Now when I say 5 meter, I included the magnitude 5 and the unit meter. This is known as distance. Means the length of the path that the person has traveled or covered. That 5 meter doesn't include any direction. But if I say that the person went 5 meters straight north on a highway, then he moved 3 meter east, then 4 meter again north, then I am including the magnitude, the unit as well as direction. When I do so, then that will not be distance, that will be displacement, which is a vector quantity. So vector quantities are those which are associated with magnitude, unit as well as direction. So here I gave you an example of scalar quantities already: mass, length, time, temperature. Another I told you just now is distance. As far as vector quantities are concerned, the examples are displacement, velocity, acceleration, these are vector quantities because they are associated with magnitude as well as direction. Now I have just now told you some technical terms including distance and displacement, which I haven't explained so far. I will be explaining. Also I told you about speed, velocity and acceleration. I will also explain about those. Now let us start with the next technical term, that is distance. What is distance all about? Just now I explained that distance is the length of the path covered by a body. You went from your house up to the vegetable market. You covered a length of 10 meter. Then from the vegetable market, you went to the sweet shop for purchasing some sweets. So over there you have covered a distance, a length of near about 2 meters. So totally 10 plus 2 is 12 meter. So the total length of the path that you have covered is 12 meter, and that is distance. So distance is nothing but the length of the path. The length of the path that you have covered is known as distance. The standard unit of distance is meter. The CGS unit of distance is centimeter. But if I say that you went 10 meter north, turned 2 meter east, came down 5 meters south, then I am including the magnitude, the unit as well as the direction. In that case, I am not talking about distance. I am talking about displacement, as simple as that. So displacement is a vector quantity and distance is a scalar quantity. Question may come that what is the nature of distance? You will say that distance is a scalar quantity. What is the nature of displacement? Displacement is a vector quantity. So I have just now explained to you about distance and displacement. Do remember that both distance and displacement, they bear the same unit. Same standard unit. The same standard unit is meter. The same standard unit, meter. Now often a question comes in the exam, that even though distance and displacement are two different entities, now can displacement and distance be same in our everyday life? Yes. Distance and displacement sometimes can be same. Now when they will be same? As long as a body continues to move in a straight line, the distance covered by a body and the displacement covered by the body will be same. The distance covered by a body and the displacement covered by the body will be same. Is that clear? So distance and displacement sometimes they can be same. Okay? There are other definitions of displacement. There are other definitions of displacement which I would like to explain with the help of this diagram. For example, this is a car and this car started moving 4 meter. This is north, south, east and west. It started moving 4 meter west and 3 meter north. Then what will be the distance covered by the car? The total distance covered by the car will be 4 plus 3, 7 meter. But if anyone asks you what will be the displacement covered, displacement will be the shortest distance between this initial, that is the starting point, and the final point. The shortest distance. The shortest distance is this one, the hypotenuse. Hypotenuse by Pythagoras theorem, you know that suppose if I give it the name A, B and C, then AC will be square root of BC square plus AB square, which will be nothing but BC square is 16, AB square is 9, which is 25, and square root of 25 will be 5 meter. So the shortest Distance is nothing but 5 meter. So 5 meter will be the displacement. 5 meter will be what? The displacement, the shortest distance covered by the body. Sometimes also question comes, can displacement be zero? Yes, displacement can be zero. Distance can never be zero, but displacement can be zero. When the initial and the starting point is same, means an athlete started running in a circular track. An athlete started running in a circular track. He starts from this initial point, finishes in the same initial point. Okay? And from the center of this circular track, he makes an angle of 90 degree. What we say that as the starting point of the athlete and the finishing point of the athlete is same, the displacement of the athlete is zero. So today I have explained you the meaning of this unit motion in one dimension. I have explained you some technical terms related to previous classes which you need to know in this class also, that is about rest and motion. I told you that they are correlated to each other. How they are correlated, that also I explained you. Then I told you about the meaning of the term motion in one dimension. I told you about scalar and vector quantities. I gave you some examples. I told you about distance. I told you about displacement. Some questions arising which normally comes in the exam related to distance and displacement, as to when distance and displacement will be same, when distance and displacement are not same, can distance be zero, can displacement be zero. I have answered those. So in my next video I will come up with some more technical terms. So there are lots of technical terms in this unit which I cannot cover up in one video. So I will come up with another video. So till now, praying that the lockdown ends very quickly, and I also pray to God that all of you are very healthy and maintaining the lockdown rules. So that's all for now. Thank you.